Hello, good morning. Welcome to my talk. My name is Rozaimi Hasan from Universiti Teknologi Malaysia, Kuala Lumpur. And my talk will be related to the seafloor habitat mapping using machine learning and the underwater acoustic sonar. So in this presentation, I will be presenting some of the works that we've done with the hydroacoustic sonar and its integration with the machine learning, and also some of the sampling to produce a detailed habitat map for a specific marine habitat marine park in Malaysia. As you all know, conservation is important, especially for the area, for the country that has a coastal water, and to manage and to conserve and to preserve this marine biodiversity and these natural resources. Most of the countries nowadays are implementing the marine protected areas, especially one of them in Malaysia. And in Malaysia, we have about more than 52 marine parks, and this is important as we have a huge number of marine parks. We have to manage these marine protected areas, and to manage these marine protected areas, we need detailed information of different habitat classes. For example, the different types of sediments, coral areas, and also the other marine habitats such as seagrass and many more. And one way to manage one way to manage the MPA is to produce detailed maps of the area, what habitats can be found at the area, and to do that, to sample this entire area, for example, almost 55 marine parks. To do the conventional method to sample area using manual sampling is not practical. It's not feasible for this area. And one way of doing this is we can use hydroacoustic sonar, which is remotely sense equipment that can get the data without touching the seafloor. And most of the time we can get the depths, okay, and also the bathymetry. And most of the latest manufacturer, they also have these options whereby they can get the seafloor reflected energy, or what they call it as intensity, or the seafloor intensity or seafloor image, which is quite useful for the underwater remote sensing. And this method can be useful to be used to infer different types of sediment, or sometimes we can use it as different to represent different types of habitats. And in this study, we use there are numbers of hydroacoustic equipment, but in this study we use what we call it as multibeam echosounder sonar, which is quite useful to get full coverage and also high spatial resolution data. You can get the resolution, spatial resolution data up to 0.5 or 0.25 meter. And we can, using this equipment, we can get more detailed seafloor data. It will provide the bathymetry and also the intensity of the seafloor. And however, okay, this information is just a physical data, the battery, the depth, and also the amount of energy, which is the intensity, and there is no information on the habitats. There are this equipment only provide us some physical data, and at the same time, whereby sampling techniques such as underwater video observation, they will provide this habitat information. So how can we combine both of this information to get this more meaningful habitat maps? One way to doing this is using this machine learning. And in this study, we propose a method to combine between the hydroacoustic technique, which is the multibeam echosounder, the ground truthing data, and also this machine learning technique, so that we can use the integration of these three tools to get a full coverage habitat maps of one specific habitat, marine parks. And our study site is located at Redam Marine Park in Terengganu, Malaysia. You can see the maps, the Malaysian map there, and is located on the east coast of this Peninsular Malaysia, on the southeast China Sea. And this is one of the marine parks we have in Malaysia. They have a variety of marine species and organism, and also a landing and nesting site for turtles. And generally, the rule is the MPA is up to 2 nautical miles from the shoreline. Okay, this is from the Department of Fishery. And we also have the information that we collected using the underwater video. We just use this GoPro mounted on the specific steel bracket, and we have the sediment types, and also we have this coral information. So both of these data will be useful for our machine learning and also this integration between them. And for the machine learning, I think most of the audience are expert in this machine learning, so I'm not going to explain this quite detailed. But what we intended to do is we would like to acquire new knowledge, which is new knowledge and new skill to identify the existing knowledge. That is, I think this is common definition of the machine learning. And in this study, we like to train the machine learning to use this acoustic data and ground truth data, and use it to predict or classify the area where the ground truth is not available. So we have this limited number of sampling, and then we have this acoustic data. We like to integrate them into a machine learning, so that this machine learning can predict the create models, which is the train data from the training data, create models, and then predict the areas where the ground truth is not available. So in this case, we will have the full detailed information of this habitat map. And in this study, we use this random forest decision tree. I think we all aware of this, one of the method of this non-parametric method to train and predict the outcomes of the data. And from the data from this multi-beam echosounder data, from the acoustic sound data, we have the main data, which is the depth, or the depth bathymetry of the area, from 0 to almost 60 meters of the depth. And we also have the seafloor intensity. It is measured in decibel. So high value of intensity means that the reflector is high, most likely refer to the hard surface like rock, gravel, and so on. And low intensity refers to the soft sediments. And also we have this. This is the using the random forest. We can also produce these different important of each variables we use. We use from the bathymetry and also the backscatter. We create a secondary variable or secondary derivative, and all of these derivatives are input to the machine learning. And from the train model, from the model, we can see which variables is so important in this prediction of this habitat map. So by doing this, we can know which variable we should consider in the future for the prediction. This is the result of the classification map. Okay, the integration of this classification has produced a prediction of the corals, coarse sand, and a fine sand for this whole area. This is the main product of the area. Okay, we also compare our prediction with the previous publication done at this area, which is only for the it is much more detailed. This publication has more detailed classification of the sediment type, but we only interest to separate between the corals, the coarse sand, and the fine sand only. And for the conclusion, the combination of the acoustic sonar data, machine learning, and sampling data has provided us ability to create to produce habitat map for the Radar Marine Park. And to sample an entire area is not feasible, but with the use of machine learning, we can do this using the remotely sensed data with a small amount of sampling data. And we can explain the variable important for each of the variable we use. And also this information is quite useful for the authority, like such as the Marine Park Authority, to plan for this further conservation action and decision making. With that, I thank you for your attention, and goodbye.